this lesson is this equation problem. We have a student draining a bucket of water. They tell you that WT, in other words, the capital W, shows the amount of water remaining in the bucket after T seconds. And I'm sorry, that's supposed to be a lowercase t. Which equation best represents this statement? Over the first 25 seconds, the amount of water remaining decreased by an average of 4 millimeters or milliliters each second. Well, let's look at each one, guys. If we're talking about rate of change, remember, rate of change is always y2 minus y1 over x2 minus x1, and that gives you slope, or in other words, the rate of change, okay? So remember that for these multiple choices. Letter A, W of 25 over 25 equals -4. So let's look at this real quick. We know we have our x and our y's. And we know our x is called the input and the y is called the output. Well, we have to understand, we're talking about water and we're talking about time. Which one is usually always the one that's the input? Always, always, always is the time. So the result for the output is going to be the water that's left in the bucket, correct? So in other words, this top is going to be the water left, and the x at the bottom is going to be the time that's passing. So should it make sense that the W is on top because it's water? Yeah. W is on top, so it's water. Whoa, look at this one. This one doesn't even have a fraction. Where's the time at the bottom? In other words, and yeah, basically you can get rid of that one too because there's no time. And also, another hint you should know, what are we supposed to get here? The rate of change. And what was the rate of change? Average rate of change of 4 milliliters each second. But is that going to be a positive number or negative? Because if you're talking about the water left in the container, are you losing water or are you gaining water when you're dropping it? You're actually losing. So another reason, this is supposed to be a negative rate of change. Same here. You're supposed to have a negative slope because you're losing water. So we're between A and D. Now, look at the bottom one. Look at the first one. W of 25 equals 25. Well, look at the bottom one. W of 25 minus W of 0 equals 25. Why does this one have W of 0 and not this one, the one in the letter A? Think about that for a second. Why is it important to include the W of 0? Well, remember, this bucket had water to begin with. So don't you have to subtract how much water you ended up with? That's the Y2 minus how much water you started with at time 0. So that's your initial. And I know there should have been a 0 here, 25 seconds minus 0 seconds. But because it's just a 0 by itself, it doesn't necessarily need to be written. This one had to be written because it's just explaining at time 0, there was water in the bucket. We don't know how much water, but we call it W of 0. So in this case, letter D is the answer because it's writing everything we're supposed to know. This one would only tell us how much water is left after 25 seconds, but we need the initial water to know the rate of change. If you don't know how much water you have to begin with, you cannot tell us how fast we were losing water.